Welcome to Gina's crash course on regulatory compliance in ontology. Today we will be chatting about traffic regulations in autonomous vehicles. First, let's have a brief look at what an ontology is. So, what's the sales pitch? I won't go into the details as I'm sure you've already seen a bunch of crash courses, but basically, the goal is to arrive at a shared conceptualization of what there is. Ontologies show that the meaning of terms are captured by specifying the constraints on how terms relate to one another in a mathematically precise way. Now that we had a brief overview of ontologies, let's look at a case where it is applied to compliance regulation in autonomous vehicles. First of all, what is an autonomous vehicle? Basically, it is a vehicle that uses sensory data to operate itself and perform necessary functions without human intervention. So, why is this a tricky concept? Basically, traffic regulations regarding autonomous vehicles are tricky as many rules are concepts instead of clear definitions. There are clear different regulations and conditions depending on the context. Think about traffic officers, malfunctioning traffic lights, different regulations in countries, or even urban versus highway settings. What if other cars on the roads are not obeying traffic rules? What if there is load shedding? These are just a few scenarios, but as you can see, it is already becoming complex. So, what is the proposed solution? Due to the fact that ontologies are both to represent and connect concepts, and concepts are the building blocks for traffic regulations, they are especially applicable in this context. As the clear semantic scenario representations formulated through ontology is both human and machine interpretable, an ontology eases the burden of testing and developing as it enables automatic scenario generation and simulations. The paper proposes both a method for semantic description of traffic scenes using ontologies and a method for improving situational awareness through semantic classification conditions. They used Protégé software to model traffic scenarios in L2 to create a working abstract ontology for a wide variety of scenarios. Let's have a look at some of them. This image illustrates the semantic description of a road segment with two parallel lane segments. Road segments are linked to traffic regulations in order to provide information. One can see the ontological properties of lanes, such as lane segment and lane marking, which is related through relationships such as is left of. Here is an example of a complex traffic scenario that the ontology can navigate successfully. It uses ontology-based decision-making, which includes vehicles with special rights, such as the tram on the left of this intersection. Let's delve a bit deeper into understanding how this solution is implemented. Classes are used to describe of which type of thing objects are. An example would be a class vehicle with subclasses car, truck, and bicycle. Individuals are objects of a certain class. For example, car 1 and car 2 could be individuals of type car. Object properties are used to give semantic description of relations between objects and are defined in triplets forming statements such as car 1 is behind car 2. Data properties are linked to individuals to provide information about, for example, vehicle speed using a data property car 1 has speed 100 with the unit kilometers per hour being stored in the annotation property. Now, what are the advantages of this solution? The way rules can be specified in a syntax which is both human and machine readable makes coding a very intuitive task. Semantic descriptions have the advantage of being generalizable over a large number of scenarios. An effective selection of model knowledge concepts leads to short and clear decision-making rules. And lastly, solely providing the region information to a road segment is enough that, using the knowledge base, it can be inferred that a traffic scenario containing this road segment must be subject to the according traffic regulation of that region. There are no clear disadvantages in this solution's implementation, but there are some general challenges with the uptake and integration of ontologies in business and government. This includes the fact that reasoning over ontologies is computationally expensive and requires careful and knowledgeable ontology design. It is easy to build bad and useless ontologies, but to build a good one requires a knowledgeable knowledge engineer. And lastly, it is a new technology and companies in developed countries have started to realize their benefit over the past 10 to 20 years. There are now many private consulting companies that specialize in semantic solutions, and bigger companies have in-house teams to implement semantic solutions to problems. But in many sectors and countries, there is still an absence of exposure to an expertise in semantic technologies. Some publications already exist which use ontology-based scenario modeling and decision-making. Mostly, they only consider a specific scenario or traffic regulations of one single country and mention that further work needs to be done to adapt it to other traffic regulations. On the other hand, the proposed solution is a framework that modularizes software code and facilitates the application to other countries. This is realized by either introducing, whenever possible, a generic way of formulating rules, or by clearly linking traffic rules to decision-making rules. The latter is achieved through using situational awareness classification. An extended framework for traffic scenario modeling and decision-making was proposed that includes traffic regulations of different countries for multiple scenarios using a modular framework. The use of an ontology is ideal, as it is human and machine readable, and was used to create a framework that was validated both in urban and highway settings. Future expansions of this model include adding more traffic rules for regions of interest and integrating the framework into vehicle architecture. I hope you enjoyed this crash course. See you next time on Gina's Crash Courses.